Hi all, this is Param. In this video, I will explain what is a compound query. Okay, compound query classes. Okay, so when we have to use, what is the benefit? Okay, so I will explain about this compound query. Uh, in most of the cases, okay, so in most of the cases, in the real time use cases or real time data analytics, we will be using compound query. Okay, it's very simple. So compound query is what? It is combination of more than one query. It could be a simple query, a leaf query, or it could be another compound query. Okay, that is what compound query, right? So the output, there are two important things in output. One is score, another one is result set. So of course, result set, that is our interest. Okay, result set is our real interest about the data. Okay, so whatever the data you want, that is our real interest in the response. The second thing is score. The score will specify which is the most relevant document, which document. Yeah, of course, for a given query there are 10 matched documents. Okay, among the 10 documents, which is more relevant to your query, that is what relevant score. Okay, that is what relevance theoretically we talks, and the score is populated for every document. Okay, relevant score means what? Of course, if you, let's say if you are specifying username, okay, or let's say your product name. Okay, let's say Philips is a product name, right? So if you are looking, if you are saying type product type is Philips, okay, then obviously the Philips word may be in other field of same data, such as same document. Let me repeat, the given term may be placed other field of in the same document. So let's say we have 3 document. Okay, in that one document has of course only the product field, other document have a description also, and other document description and feedback as well. Okay, so then obviously the third document has in 3 times, okay, in the different field of the same document. Okay, so then that will have more score, right? So that is what that's how score is calculated. Okay, of course some statistical also they are using for different types, but we should think we should consider like two things. Okay, one is result set itself, another one is scoring. Okay, that's all. That is about the that is very important thing about the query. Okay, so now let's talk about the different types. Okay, of course here you are seeing, right? So boolean, boosting, disjunction max query. Okay, then of course function score. There are, so okay, of course all 1 2 3 4 5 types. 5 type of queries comes under the compound query. Okay, but the everything is not based on the data types. Okay, all these classification is not based on the data types. Okay, as I discussed in previous video, it is based on the how they are calculating scoring. Okay, how they are calculating scorings, or how they are now give query values, or what are the options to how to modify the scoring, how to tune the scoring score calculations, everything. So based on that, these categories are there. Of course, the very easiest one is boolean. Okay, so booleans we call it a bool query. Okay, we call it as a bool query. So bool query can have must, filter, must not, then should. Okay, should. Okay, so it can be these 4 items. Okay, all of this can be object itself, or all of this can be array. Okay, that is very important. Okay, I will show the demo. Okay, by end of this video I will show the demo. Okay, but all these 4 block can be object itself or as array of objects. Okay, that is what. Second things, filter and must not. Okay, these two is not part of the scoring calculations. It's just okay. See why we have, what is the benefit of filtering? You know, we can simply cache the data. That is a beauty. Okay, so let's say if you do the filtering, okay, what happen? The data is stored in the cache. Okay, so cache means what? But when asking next times it comes immediately, right? It can return immediately. So that is a benefit of caching. Okay, so that's why score value is not calculated during the filter class. Okay, now I think I have explained, right? So then for should, if you are using should block, okay, let me highlight, put it to bold. Then you should say minimum should match. You can say like how many records should match to get the to part of these documents. Okay, okay, so how many things, how many records should match, okay, minimum, okay. Then boost, boost is just is a field to declare the uniform, to declare the uniform that uniform additional numbers to add to sum in the scoring, okay. So as I said, all the compound query result two things, right? One is matched record as well as scoring, okay. So and how it helps for scoring is different syntax, that's it. But obviously every query will play the important role to give the more productive or more scoring related feature as well, okay. Then of course, let's say we are having like four block of query, okay, or four type of query within the single request, right? So we should obviously what we may need to know which document matched by which query, okay. So that is what, okay. So that is what we call as a named or labeled query support. Okay. So you can give that key as your key one parameter. I will show that demo as well, okay. See, that's all about the Boolean query, okay. Boolean query is a very often usage, okay. So in my experience, okay, so I am using more Boolean query in real use case rather than other query, okay. Of course, I would say like, see, why the scoring is important. I think I have explained, okay. Scoring just a floating point number, so it how best match, right? So out of 10 records, I want to see only top three records by the scoring value. So okay, by the scoring means I am giving more important to the document, okay. Okay, so I am giving more important to the documents. Okay. So what would be the real use case? Okay, it can be enterprise search, right? We have one feature in Elasticstack, enterprise search, right? So there we will do searching, right? For the given document, okay, mostly related document has to be in the top, right? So that is a place where scoring value may be play very important roles. But in my case, okay, in my use cases, mostly I would write in a watcher, okay, based on the on data, okay. So just matching criteria is a matter important for me rather than scoring. So I never worried about the scoring. But the real use case would be enterprise search applications, okay, enterprise application, or if you have any front end application there you have functionality to search something, then scoring is play the important role, okay. That is a real use case of the scoring. Okay, then next thing is constant score, okay. Constant scores, see, okay, one more thing. So okay, we want to do, see, wrap the filter class to provide the constant score equal to the boost parameter. I tell you, this is another type of query. So it's wrap a filter query. I will show the demo as well, okay. It is wrap a filter query, okay. So as I said, filter is not doing anything, right? Okay. So let's say in your case you want to do search, you want to do filter your document, but at the same time you want the scoring as well. Then what is the way? That is your constant score. The constant score will give the equal value for all the documents. Though you are doing filtering, okay, but still if you want scoring, then constant score is the option, okay. So that is what it will always wrap the filter query, okay, for selected document, and then it assign the default constant score is a given value, okay. Now I will move. So this is a one type, right? See, that's what. See, Boolean assigning and Boolean calculate the scoring is different way. So constant scores calculating or assigning scoring for each document is different way. Now boosting. What is now? See, we have two types. Okay, we have positive and negative block or search or just an object. Okay, what is now? It can have multiple query. That is fine. Okay. Now what you can do now? So the positive case, it will create the query, and for those documents scoring value is calculated. Okay, calculated. For the negative also, right? For the negative also, what is now? Let's say for the given criteria, it is in response. Okay, but you don't want to calculate scoring for those records, or you don't want to influence those documents in the scoring calculation. Then that query has that type of query will be put in the negative query. So that means giving importance, that's what they will say, okay, by decreasing score of the document without excluding from the search result, okay. So that means I got 50 documents, okay, I got 50 documents, okay. So let's say I am searching about the product, okay. So for the Philips products, I want to give I want to get the real scoring, but at the same time I want to see the BPL product as also, but I don't want to calculate scoring for them, okay. So obviously I want to give PPL product as a low priority. So in that case, okay, I will be using boosting query, okay. So that is a sample, okay. So based so both positive and negative matched queried document or matched queried document will be part of the response. But the only thing is that scoring only for only some set of document, that is part of the positive query. For negative query there will not be any scoring. So obviously each types differ how they are calculating or how they are affecting their scoring, okay. Now this junction max query, okay. Okay, now I'll tell you distinctions, okay. How now let's say I have it's also multiple query, okay. It's also multiple query. I will give multiple query in the single request, okay. For each query, since multiple query now, okay. Now how the scoring has to be calculated, okay, or which is all three query will be calculating scoring, right. Now I want to do either multiply among them, or I want to do max of that value, max of this query scoring value, okay. How I have to select? So that is what that is what I can use the disjunctions match max query. So obviously what will be now, I'll tell you the sample. Again in the for a request given request, we have put 4 queries, okay. A document is matched almost 3 for 3 query, okay. Now a document matched on this 3 query, okay. Now what is now, each query will calculate different scoring, right, obviously, okay. So since scoring where is calculated, scoring is calculated in the chart itself, okay. So in this case what we will do now, as I said, a single document matched for these 3 query. So which query calculate maximum value for the scoring value, then that query is mapped, but then that scoring value is taken, that is what max. Let's say I think I have explained very clearly, okay. Since it's multiple query, I have given 5 query in a single request, okay. A single document, assume that based on the price or based on the date release or production date, something, or some serial cannot be, or customer something, okay. So all these so yes, a single document matched for 3 queries. So each query will calculate score value, okay, for the same document, okay. Now I want to take maximum of these 3, that is what disjunctions query, okay. So this also is a type where I want to get maximum score value, okay. That is for use case. Now I think I have explained. The last one is function score, okay, fine. Now all these type 1, 2, 3, 4 I have explained it in constant score, boolean, boosting, this junction max query, right. So all these 3 are fixed, okay. Only we can give the structure, or we can select based on to match our criteria or match our use case, okay. But the calculation of scoring is not to our case, it is not to control in our case, it's not our control, right. We can say do this, that's it. We can give the instruction, but we don't have complete control about to change or to modify the any scoring, right. Then if you want to modify your scoring, then you have to go for function score type of query. This is also multiple query, okay. This is also multiple query. You can give array of functions in your query, okay. So here also we will be using query, okay, but we will be using built-in function, okay. We will be using built-in functions to manipulate or modify our scoring value. So that means what, we have more control about the score calculation of each document. That's it, okay. So we have more options, okay. We have more control. That's what, okay. Let me give the same another color. It is all the same. No, it's already there, okay. No. Let me green, blue, yeah, cool. Okay, So whenever I want to have whenever I want to have more control on the scoring, okay, then function score is the only options, okay. And then of course filter is must, minimum score, okay. Let's say I want to have scoring usually will be 0 to 1 most of the times, okay, most of the time 0 to 1, okay. That is a standard, okay. If I want let's say if I don't want the document which is score value is minimum less than minimum 0.50, okay, I can avoid that also, okay. Okay, so I can avoid that. So here what are the functions are there, so that is what we are going to discuss now in detail, okay. So we have built-in functions, then score mode, boost mode, okay. What is this? I'll tell you. Built-in function. So based on the built-in function only, we are going to identify which type of functions we are going to use for scoring calculation, okay. For random score, that is one. So whenever you want to have reproducible score value, we will be using random score. I am giving the same query parameter again and again, okay. So if I do 10 times query, if I request the 10 times, so in the response the particular document should be the same scoring value, then I will be using random score. Script score, okay. Script score, what is now? We will be writing script, okay. Any math function are obviously painless, but it's work on the only numerical field of the docs, okay. I'll tell you it must be field of the doc. That is build field of that is important one, okay. Field of the documentations. Weight, okay, so it's common, sir. It is very common, okay. So we will be normalized, okay. That's what we will say, normalized, okay. I think normalized, right? Because we will give without any functions weight 2.5. Then what is now? All the document will have 2.0. Then there is no difference. So we normalized the all the scoring document. See, we cannot do achieve anything the same thing in any of this, okay. Here you can do boost already 1, then you can do boost plus 1, then 2, it will become 2. If it is 0.5 already, then it will become 1.5. So you can do boost, you can degrade some things, okay. Here you can say constant value for all the stuffs, okay. Okay, then this function is again is different, which is maximum that score will is taken. So that's how here if you want to normalize for all the value, then we can use the weight, okay. I think the built-in function weight and the constant score must be same, I think. I don't know what could be the difference, okay. Then filter value factors, okay. It's also like a numerical value, okay. It's also part of numerical values, come on, numerical values, okay. Then this is Gauss linear functions. It's more complex, okay, but come on, no, cancel, okay. But the Gauss linear expressions all are working in the shape based query, shape type field of doc, okay. So these are all we can say like it's a feed, okay. It's a feed to that for the scoring calculations, okay. You can the particular field of the document is used for seed calculations, for score calculations. So that's how almost you can see, right. Script score, field value factor, guess linear expression, all these type of built-in functions you use the any field of the given field of the document, okay, given field of any documents, okay. Then the scoring mode, okay. So scoring mode is could be a multiply, see for the random score also uses score mode. So which function has to be sum, multiply, average, filter first, okay. Then boost mode, okay. Boost mode is replace, multiply, sum is okay. So these are the boost mode, these are the score mode, these are the built-in functions, okay. Boost mode and the score mode is usually within this built-in function, okay, within this built-in function. So I will tell you the samples, okay. Once I show the samples, you can understand. So now you understood, right, what is the compound query, okay. So of course we have talked about 6, I think 1, 2, 3, 4, 5, only 5 is 1, 2, 3, 4, 5, 6, right. Yeah, of course we have seen 6 type of compound query. These from this the compound query means of course more than one query, right. It's more than one query, nested the query, okay. So two things we will get out, one is scoring value and the one is result document, okay. So of course most of the query, most of the types is classified, the type is categorized based on how the scoring value is calculated for the document. That's it. How the scoring is affect on the document. Based on that only these many kind of a type of compound query has been defined or enabled in the Elasticsearch DSL. Thank you. Thanks for watching. I hope you will enjoy this video. Okay. I think I can show that. No. No, Postman. Yeah. Here, of course, as I said, it's the query DSL or aggregations is all part of the data analyst. Okay, analyst. Okay. Now, of course, we have seen aggregation and we have seen search context parameters. Okay. Now we are seeing about the query. Okay. So as I shown, within the query we could see compound query, other type of things yet to add here. Joining query, leaf query set yet to add here. Okay, that is fine. Now we will show the demo about the boolean compound queries. Okay. So in the compound query, one type is boolean. I think let me close this stuff. Okay. This is function score type of the query. Okay. Now of course constant score, then boosting. Boosting is positive negative, right? Then disjunctions. Okay. Let me open here disjunctions. Okay. Here I have given many query. 1, 2, 3. Okay, so of course two things are there. Okay, tiebreaker 0.7, that is fine. Okay, so obviously which documents, which query give more value for a single document, then that value taken. Here boosting, obviously we will have positive and negative block here. Okay, this is query syntax. So of course we are taking this one and this ones. Okay, so what will happen? So the scoring calculator for this query. For this one, query is sorry, the result set is returned. Okay, but this query is this score value is not calculated. Okay, then what is the difference between filter and negative? For filter case also does not calculate, right? Okay, I'll tell you. In the filter case, what we will not get the record itself. If it is filter, the filter itself, it is yes, we can say filter also, right? So this record we can get. Then what could be the difference between negative and the filter? Sorry, I have no idea. Okay, but the negative case they will say like decrease the scoring value of this document. Maybe I think based on the positive records, will it affect the negative? I don't know. Okay, then constant score. Where is the query? Yeah, constant score is normalized one, right? So we will get the document by this filter. Obviously, filter does not it will cache document, but it does not score the document. So that means I have cached the document, right? So if it's a forum, again I will get the result set from the caching itself. Okay, then it boost already is 1, then 1.3 has added something like that. Okay, then it became 2.3. Okay, now function score. Function score, the purpose of the function score is what is done. We want to modify the score value with more customized manner. So that is where score function is there. Okay, you can see is a method. It's a boost. How to boost? Okay, it's a boosting. It's a boost method, multiplier, or something like that. Okay, sorry. This is using a script. Of course, we are using numerical field of the document, and based on the scripting, we will be changing the score value. If it is a field values, again here also we will be using the field name. It's a numerical field. Okay, using the field value, then we will do some modifier calculations. Okay, square root, something there are square root, then what multiply, many things are there, something like this. Okay. Using this modifier, we will calculate the scoring values. Okay, this also use the field of what? Field of document itself. Okay. Now guess are working with data type of point, geopoint or shape, something like that, or point, shape or geopoint, something like that. Okay, for those data types field we can use. So obviously in the graph in the Google map, okay, we are searching, right, from target to which location, so which is the nearest hospital, which is the nearest to nearest hotel or ATMs. Okay, so that is, these are the things. Guess. Score, can you script score? Of course, we can use the parameter as well. Okay, we can use the parameters as well in scripting. Okay. Yeah, here we use more than one function. Here we use more than one function to filter out. So and then of course boost score mode, boost modes are already applied. Okay, maximum boost value, what is minimum boost score value? It should not go beyond 42. Okay, so that's all about the function. I think then boolean, of course, you would see like filter as a term array. So filter is array. Okay, now here must is object. Must is object. They can filter also such object. Okay, then here you can also hear what again, must is object, filter is object. Then here what it says, filter is object. Okay, here you can see filter as array, right? Here is filter is array. Even with this boolean query we can add aggregation as well. I think this is what, this is also boolean with the term array. Yeah, filter array, right? Okay, filter array with the terms. Okay, so this is the what boolean query. Okay, I think this is what about the compound query. So I think I have explained in very detail. Of course, sorry, it's a very lengthy video, but I want to cover all the stuffs. Okay, so I have covered in single video. So that's all about the compound queries. It is one type of the query DSL. Thank you. Thanks for watching. If you like the content, leave your comment. Please subscribe. Okay, share it with your friends. Thank you. Thanks for watching.